Hey guys, a lovely good morning to all of you. My name is Avinash and once again welcome back my channel The Learning Destinations. Today once again I am back with another fantastic ML topic, and this is about the tokenization and embeddings. So now let's first understand why do we need tokenization and embedding. And guys, if we talk about the NLP, that is natural language processing, neural network comes into the picture. And if we feed input in form of text or speech to the neural network, it doesn't work. It means we must need to change the input format, which is currently in text or speech format. We must need to convert it from word format to another format, and there the tokenization and embedding comes into the picture. So in this sessions I'm going to completely explain you about tokenization and embedding. So sit back, relax, have a sip of coffee and enjoy these sessions. Okay guys, so I'm going to cover following topics under this sessions. First, I start with NLP, where I give you a short introductions about the NLP, and after that I take you through the various parameter of NLP like tokenizations, how we can arrange sequence in correct order. We will see out of vocabulary. Then we will go through the padding and truncating. After that we will see the embeddings, and finally we end the sessions with the embedding layer. So I can see that this is going to be one of the best short, crisp and clear sessions to get to know about NLP. Now let's first understand what is NLP, or natural language processing. So it is a process to analyze text and speech data, and it does the sentiment analysis. It means when we provide the input, and after the NLP process, it analyzes whether the sentence was positive or negative. So here we can understand we have one of the input like Ramesh is an excellent cricket player. When it goes through the NLP process, now you can see that we are getting the positive response, and that's the reason that I have given here the smiley face. Now yesterday I had dinner in a restaurant and food wasn't nice. Now it is a negative because I have some awful experience in the restaurant, right? That's why the after the NLP processing there is a sad face. It means it is a negative review. So that is how the basic fundamental of NLP works. All right guys, so before I jump into the tokenization sections, let me take you through this. So basically we are, as of now in NLP, we are preparing the data, and we have to go through three process. First, tokenize the words, which we will see just now. After that, we will create the correct sequence, and then finally we will maintain the equal length of the input. So these three process we are going to see that. Now let's jump into the tokenization, and we have this input and we want to process it through the NLP. Now in such cases, this input has to go through several layers of neural network. Now current input is in the form of text, or let's suppose if it is in form of speech. Now neural network doesn't understand if we directly process it, okay, because neural network doesn't take the input as in text format or speech format. For that we have to assign it to the number. So this is complete one sentence, so we have to assign numbers to each word. Okay, now assigning numbers to each words, this process is called tokenizations. Now we are going to see that how tokenization works. All right guys, so here I take one example. Let's say my name is Avinash and I am a ML engineer. So this is a complete one sentence. So here we need to assign numbers to each word. So here you can see that I have assigned numbers to each word. There is a word my, so I have assigned the number 1, name 2, is 3. In such a way I have assigned numbers to each word. Now we have the second sentence, and here I also assign numbers to each word. However, there is some common words over there. Now you can see that here is the common, and is the common, and what else is the common? I think only 2, right? So okay, so my name Avinash is also common here under these two sentences. Okay, so you can see that both the common words, all the common words is having the same number, like is having 3 under this sentence, and it is also having the 3 under this sentence. Okay, in the same way for Avinash and is having the same numbers. Okay, so in this way, under this tokenization process, we are assigning numbers to each word under this sentences, and this process is called word indexing. All right, guys. So far now we understood that what is the tokenization and why it is needed, and we also see that how we can assign the numbers to each word, or what is the word indexing. Okay. Now there is a question comes. We can also assign the numbers to each alphabet, but if it does so, right, then there is a problem. The problem system won't understand correctly the meanings of each word. The reason, let me give you one example. Now you can see that there is a word called loop. Now using this four alphabet, we can form another word, pool. In the same way, there is a word life, and using this four alphabet, we can make another word file. So if we start assigning the numbers to each alphabet, then both word is having the same value, same numbers, but the meaning is changed. Here there will be a problem. System won't understand the actual sentiment of the word, and that is the reason that uh, we don't assign numbers to alphabet, we assign numbers to word. So now I think the concept is pretty much clear why we assign the numbers to word, not on letters. Okay, guys, so far now we have seen tokenize the word, and now we are moving into create sequence for the sentences. Okay, and we will see that why it is necessary and what is the meaning of correct sequence. Okay, so first let's see the what is the definition says. If the sentences are not in the correct sequence, and due to this there is no proper meaning of the sentences, then the sentence needs to be arranged in proper sequence, right? Let's understand through this example. So I have one word like I of coffee want a sip to have, right? So this word doesn't have any meaning. Okay, but if I arrange it in a proper sequence, like I want to have a sip of coffee, everyone will get the actual meaning of the sentence. Okay, now here you see that I too have want Starbucks coffee. Again, this is very messy sentence, doesn't make any sense here. But if I write I want to have, the words are the same, only I am arranging the proper sequence. Okay, so I want to have a Starbucks coffee. Now it has the proper meaning. Okay, so in ML model, if we pass input something like this which is not in proper sequence, system won't understand the actual sentiment of the word, and that is the reason that we need to give the complete sentence into proper sequence, and that is the reason that we need to take care of proper correct sequence. Okay, now again I have done the, here you can see that the word indexing of each sentences under each word. Okay. Okay guys, so now I explain you one of the important topic of this sessions, but before I jump into that, I take you through this query. What if the word being sequenced is not in the word index? Okay, what it is saying that, let's suppose if there is any new word comes here, I say I just added biscuit, right? So I want to have a Starbucks coffee and biscuit. Okay, so if new words comes, then in such cases how the system handles this situation, because system is only knowing about these words, and system has done the word indexing for these words only. Okay, if any new words comes, how the system handles. Okay, so in such scenarios the concept called out of vocabulary, and which is also known by OOV. Okay, now let's see the definition. If there is a new word in sentence that is not part of tokenizer vocabulary, then tokenizer ignores it and doesn't include them in tokenized sequence. Now here we use the concept called OOV. It is an important consideration in NLP, especially when working with the models trained on a specific data set with limited vocabularies. Okay, now I give you small definitions of the vocabularies. Okay, so when we set the input, when we pass the data, we set the vocabulary size over there. Okay, so let's suppose that in these two sentence I pass the vocabulary size of 20, and I say to the system, hey, only select most common 20 words from these sentences. Okay, so now 20, which the numbers which I have given, that is my vocabulary size. Now if I introduce some new words which is not part of those 20 common words, right, then this is out of our, these words is out of our vocabulary. Okay, out of our vocabulary. Then in such cases we can use the concept of out of vocabulary. Okay, so here I have given one example, like let's say I want to have a sip of coffee. So in this sentence I was having only I want to have a sip of coffee, And while arranging into proper sequence, let's say we have the new word is also introduced. I want to have a sip of coffee and pancake. Then how system handles? So in OOB, basically we assign one value to this OOV, one token. Okay, so we assign token 1 to this OOV, and that's the reason now you can see the word indexing. I want to have a sip of coffee until here, coffee, and then and pancake. These two are the new word which is not part of our this sequenced sequence sentence, which was not tokenized, right? So it has assign the value of OOV, which I have given here 1. So by default, the value is assigned to 1 and 1. Okay. So that is the concept of out of vocabulary. So when you sequence the sentences and new words comes, okay. So in large data set, basically when you sequence the sentences and new word comes, so those kind of situations we can handle it by introducing out of vocabulary, which is also known by OOV. Perfect, guys. So far now we have completed tokenize the word and create sequences for the sentences. Now we jump into keep all the sequences in the same length. Okay. So how we can keep the length of the inputs in the same size? Okay. So here the concept called comes into the picture, that is called padding and truncating. Okay. So after converting input sentences to numerical values, still it is required to provide equal length of input. That is the definitions. Okay. Now I'll explain you padding and truncating, but before that, what does it mean? Okay, so now you see that we have two sentences, I am Avinash, and we have second sentence, Ramesh is working on artificial intelligence. Here what it is saying that to feed the input, to take it through the NLP process, we need to maintain a proper length of the input. Now, if the second sentence is having 1, 2, 3, 4, 5, 6. Okay, so it has 6 elements, and the first sentence is having only 3 elements. So how we can maintain the length? It means according to the proper steps, we need to maintain the length. Okay, so in such cases, we add the padding. When we add the padding, when we have to maximize the length. Okay, when we have to match the length, it can be done through two ways. One is padding, okay, and second one is truncating. In truncating, we are just shortening the length of the input. Okay, so in padding we add additional 0, and now by default it is the padding is added on the starting of the sentence. It means the 0 will be added here, 0 0 0, and then I am Avinash, like that. Okay, and you can do pre and post padding as well. Here I have shown the post padding. Okay, so after adding the padding here, now you can see that word indexing. I am Avinash 1 2 3 and 0 0 0, that is padding. And here I am adding I am using the padding to match the length of the input. Okay, and now in the second sentence 4 5 6 7 8 9, so both the input is having the same length, both the input is having the 6 element in both the input, and that is called the padding and truncating. So this is the example of padding. In truncating, we are just shortening the input length. Okay, and it can be done pre and post padding, pre and post truncating. By default, pre padding is done. It means this 0 will be added on the starting of the input. So that is the concept of padding and truncating. Now we will move towards the embedding. All right, guys. So finally, now it's time to understand the embeddings. And at this moment, the system does the sentiment analysis. It means it passes the review whether it's a positive or negative sense of the sentences. So first we see a short definitions of embeddings. This is the cluster of vectors in multi-dimensional space, and each vector represents a given word in that space. Okay, now here you can see this image. This image is generated basically through the TensorFlow 3D projector, and you can see all these blue dots. Each blue dots represent a word. Okay, in multi-dimensional space, you can assume how it does the sentiment analysis. So in multi-dimensional space, there is a some word on the right hand side. You can see that wonderful, happy, lovely, awesome, joy. These all are the positive words. Okay. Now you can see here these all blue dots. In actual conditions, these words, it is represented in these blue dots. Okay. And all the negative word on the left hand side, you can see that sucks, sad, worst, pain, unfortunate. These are the negative words which is on the left hand side, and that is how in NLP process the system identified whether it's a positive sense or it's a negative sense. There are some ambiguous word which doesn't have any sense, which present at the middle, like a, is, those kind of word which doesn't have any sentiment. Okay, so basically embedding is the process where uh, clusters of vectors in multi-dimensional space, and each vector represent a given word in that space. Okay, so this is the complete definitions of the embedding. Now we also understand that how system analyzes. Basically it divides the word into multi-dimensional spaces, and it divides the positive and negative sentiments of the words in different dimensional spaces, and accordingly it see that which are the closer to each other, and accordingly it determines the complete sense of the sentences, and it gives you output. Now finally there is a embedding layers. To achieve this embedding, we need to create the embedding layers, and basically three input are required, three arguments are required. One is tokenized vocabulary, which we have seen, numbers of embedding dimensions, okay, we define under this process, and input length. We just now have seen this input length here, padding and truncating. Okay, so this is the complete process of NLP, and we have gone through the several definitions and in depth the actual working conditions of each parameters. Okay, NLP, tokenizations, correct sequence, out of vocabulary, padding and truncating, finally embeddings, and then embedding layers. Alright guys, so that's all from this sessions, and I hope you thoroughly enjoyed it. Now let's wait for the next sessions, because in next sessions I'm going to cover RNN, that is recurrent neural network, and LSTM, long short term memory. So if you haven't yet subscribed my channel, then do subscribe, and I will see you in my next tutorial. Till the time, thank you so much for watching this. You have a lovely day. Bye bye.